The next topic in chapter 10 is two sample test for population proportions. So we have two populations, so each with zeros and ones, only two pass success and not success. So proportion of success pi sub 1 for the first population, pi sub 2 proportion of success in the second population, and we want to test whether there is a difference between these two population proportions or not. So we take random samples, there is no paired sample here, only random samples, and we compute the proportion of success in the first sample p sub 1, proportion of success in the second sample p sub 2, and that's our point estimate. And this is the condition that must be true for the samples to be considered large enough for us to be able to use the normal distribution. So we have n sub 1 times pi sub 1, n sub 2 times pi sub 2, okay, n sub 1 times 1 minus pi sub 1, 1 minus pi sub 2. So they all must be, or in other words, if you're looking at samples, the number of successes and the number of failures the sample must be large enough such that you have at least 5 successes and at least 5 failures in each of the two samples. That's what it amounts to. Okay. Now in the case of hypothesis testing, okay, not confidence interval, only for hypothesis testing, where we are testing whether pi sub 1 is equal to pi sub 2. In other words, pi sub 1 minus pi sub 2 is 0. So if the two pi's, the two proportions are same, then maybe we can pool the two samples together and find a single estimate for that equal proportion. Okay, instead of if pi sub 1 is equal to pi sub 2, which is equal to pi, which is a common proportion. So that's what this is. You add the successes in the two samples and divide that by the total sample size. So this is the pooled estimate of the population proportion. Then this is the formula that we can use for testing, and here is a z-test. It's not a t-test. Proportions are always z-test. So p sub 1 minus p sub 2 minus the hypothesized value, which is usually will be 0, and then you use the pooled value for the proportion. So p bar times 1 minus p bar, and then 1 over n sub 1, 1 over n sub 2. So remember, p bar here is the pooled proportion. And of course we have the three flavors of the hypothesis: the lower tail one tail, upper tail one tail, and two tail test. Okay. And the corresponding rejection regions, we use Z. And here is an example of that: a random sample of 36 of 72 men and 35 of 50 women indicated they would vote yes for that proposition A, and we want to test at 0.05 level of significance whether the proportion of male and female who will vote yes are the same or not. Okay, so you have the samples here, and then you pool the samples and plug them into the formula, and you get your results. So now let's look at an Excel example.